If you're building software, you know about TDD, or test-driven development. Write tests first, code second, and ship with confidence. It is the gold standard for reliability. But here's the disconnect. AI does not work like traditional software. It's probabilistic, not deterministic. So binary tests don't capture model behavior. Pass, fail metrics means the nuances of performance, bias, and accuracy. That is where evaluation-driven development comes in. It evolves TDD into EDD, or evaluation-driven development. It's not a replacement, it's an evolution. This systematic framework that transforms AI engineering from guesswork into measurable optimizations. And that's the foundation for AI systems that are truly reliable. So, I'm William Caban, Product Manager for Generative AI in Red Hat. Let's talk about this. Let's quickly recap test-driven development, or TDD, and its famous red-green refactor cycle. In the red step, that's where we start by writing failing tests. You're describing the functionality you want or the bug you need to fix. The test fails. Of course, it does, because you haven't written the code yet. That's your red state. Then comes the green. Now you write the simplest code possible to make that test pass. No gold planting, no over-engineering, just get to green. The test passes, you're done with this step. Then comes refactor. Here's where the magic happens. Clean up your code, improve the design, optimize. Your tests are there to catch you if you break something. Then you repeat, red, green, refactor, over and over and over. This cycle gave us a systematic way to build reliable and maintainable software. But notice something. It assumes binary outcomes, pass or fail, red or green, black and white. And that is where we hit the wall with AI. Traditional software is deterministic. Same input, same output. Every single time. It's predictable, reliable. AI and LLM systems, they are probabilistic. Same input can produce varying outputs. And here's the kicker. All of them might be correct. In traditional software, we write tests to assert exact outcomes. The test says, does the output equals to the expected result? So it's a pass or fail. It's a binary. It's very simple. But with AI, that breaks down. Let me give you an example. Say you're building an AI system to generate executive summaries. You write a test that asserts the outputs equal to revenue up 15% year over year. Now, your AI generates responses like, hey, on Q4 quarter revenue increased 15% compared to last year. Or earnings show 15% revenue growth. Or annual revenue rose by 15%. Any combination. All factually correct. All semantically accurate. All failing your test. Here's the paradox. Your test might pass only 20% of the time, but your model could be performing correctly 100% of the time. And this is exactly why the traditional testing paradigm falls short for AI systems. So we need something more sophisticated, We need evaluations and not just testing. So how do we solve this? This is where we introduce evaluation-driven development, or ADD for short. ADD adapts to AI probabilistic nature. And just like TDD has its red, green refactor cycle, ADD has its own three-step process. Step number one, define evaluation criteria. So this happens before you write a single prompt, before you choose a model, before you do anything else. You establish how you will measure quality across multiple dimensions. For example, factual accuracy, relevance, tone, conciseness, whatever matters for your use case. At the end, you are setting up your North Star. That is step number one. Then, step number two, the actual evaluation. Measure this quality score. Now you run your system and assign score, and they will be in a range from 0 to 100. So it's not pass or fail. It's not binary. There are percentages. There are gradients. They capture the nuance. These give you a baseline, a benchmark, something measurable. And with that, we can go now to the step number three, which is iterate and optimize. This is where the actual magic happens, because you will iterate on prompts, tweak configuration, maybe even swap models. But all of this based on the measurable improvement against the criteria you define on step one. So you're not guessing. You're optimizing systematically. This is the EDD paradigm. And it's how we build AI systems that do not just work sometimes, they work reliably, and we can measure and do that at scale. So let's go and break down a little bit more evaluation-driven development. How does it look in practice? We'll start with step number one. Define your evaluation criteria. This is where you answer two critical questions. What matters for your specific use case? And what is the minimum acceptable performance? So you're not just setting goals. You're establishing measurable thresholds before you build anything. Let's take, for example, let's say that you're building an AI product recommendation system for an e-commerce. Your evaluation criteria might be organized then by product categories, like electronic, clothing, home goods. And for each category, you set a minimum threshold. For example, maybe you decide that electronic recommendation must maintain a relevance score of 90% because you need high precision for that. Now in clothing, it probably can be a 75% because you want to allow more room for discovery, because now the models can also be more creative. And for home goods, let's say you set up that to 80%. You're being explicit about what good enough look like for each context. Another example, let's say in healthcare. Let's say you're building a medical information assistant. Your evaluation criteria then might be organized by medical specialty, cardiology, dermatology, neurology, etc. But then, not only that part of the evaluation criteria of, let's say, factual accuracy, because you can probably say, oh no, I want my factual accuracy to always be above 95%. It's non-negotiable. But now you can add additional dimensions, like, for example, completeness. And now it's not only about the factual accuracy, but let's say for cardiology, I need a 90% or higher on the completeness dimension, or 85% for the dermatology, or the tone for all of this need to be at least 80% minimum. So you're setting up threshold on granular and in more dimensions. The key insight is that different contexts demand different criteria and different thresholds. So step one is about being intentional. What dimensions matter? What scores are acceptable to your use case? Define this upfront, and everything else becomes a systematic optimization. Now, let's go to step two. Measure the quality and assign the scores. This is where you answer the critical question, how good is my AI system performing against the criteria that matters to me, to your use case? So let's continue with the e-commerce example. Remember, you set up threshold, electronics, 90% minimum, clothing, 25, and so on. Now you run the evaluation and you get actual scores. And let's say for electronics, you got an 82 out of the 90. Clothing, 95, so, you are exceeding expectations. Home goods, 45. So significantly below your threshold. Now you have visibility. So here is this, you can see exactly where optimization matters. So electronics is close enough, it's about 8 points. But home goods, in this example, that's a 35-point gap. That's where you should focus your effort. And this is the power of evaluation-driven optimization. It pinpoints where you should spend your effort. So evaluation-driven development creates a continuous cycle. Evaluate, learn, iterate. And this cycle has 3 core characteristics that transform how we build AI systems. The first characteristic is evaluation-driven model selection. And this is an important one that we usually forget. So instead of relying on hunches or hype, you use evaluations to test and compare multiple candidate models against your specific use case. You're not asking which model is the best in general. You're asking which model is the best for my application, for my use case. The evaluation answers that question with data. So that's the first characteristic. The second characteristic is a systematic prompt optimization. And in this case, is evaluating in a way that you have an A/B test of different prompt variations and comparing their output against first a known ground truth, a human preference, and your defined criteria. So you're not tweaking prompts based on gut feel. You are running actual experiments. You're measuring impact. You're finding the prompts that actually work. And the third characteristic is moving from a black box to an optimization problem. And here's the paradigm shift. EDD reframes AI development entirely. Traditional approach, the LLM is seen as a black box. You put something in and you get something out, and you hope it's good. The TDD approach, it is an optimization problem, meaning you have the current performance because you have your baseline score. You have the desired performance because you have set your threshold. And you have a measurable gap between them. And your job is to close that gap systematically using evaluation metrics as your guide. So you're not longer flying blind. You are optimizing with precision. So let's bring this full circle here. Why do traditional tests fail for AI systems? And why must we move beyond the binary pass-fail metrics? It comes down to the fundamental difference. Traditional tests expect perfection. They ask, is this exactly right? So they're binary, deterministic, zero tolerance for variation. AI evaluation expects and reveals progress. It asks, how good is this? And how can we make it better? Is it improving in the right direction? So it's gradual, it's probabilistic, designed for iteration. In traditional software, a test that passes 80% of the times means you have bugs, you are failing. In an AI system, an evaluation score of 80% might mean you're ready to ship. Or it might mean, no, you need to optimize a little bit more. Either way, you have visibility, you have a baseline, you have a path forward. That's the paradigm shift. We're not chasing perfection. We're engineering progress systematically and measurably. And that's what makes evaluation-driven development the foundation for reliable AI systems. Let me leave you with this. Building AI systems that actually solve real problems means recognizing that evaluations is not optional. It is not a testing phase. It is not a nice to have. Evaluations is the foundation of a reliable AI system. So, if you want to build an AI system you can trust, system that you can go and deploy with confidence, here's the blueprint. Define evaluation criteria upfront. Measure quality with scores, not binary tests. And then iterate on prompts configurations based on where the data is pointing you. In other words, adopt evaluation-driven development. And this is how we evolve from TDD to EDD. This is how we move from guesswork to systematic optimization. This is how we build reliable AI systems that the world needs. Thank you.